So as we know from the previous problem, the house and the ground and the ladder form a triangular region, and part B asks what's the rate at which the area of this region is changing at the exact moment from the previous problem. So remember, in the previous problem, or previous part, we know that the B was changing at a rate of 14 feet per second, and A was changing at a rate of negative 48 feet per second, which makes sense that the answer, that A would be negative since the top of the ladder is dropping towards the ground. So we're interested in the rate at which the area is changing. All right, so area of a triangle, we know, is 1/2 the base times the height, where the height, in this case, would now be what A was before. B is still the base. All right, so when we're finding our rate at which the area is changing, in other words, we're taking our derivative, we have to use the product rule. All right, we have 1/2, that's our coefficient, and now it's time to derive B times H. Derive the first times the second plus derivative of the second times the first. It's a product. We have to use the product rule. All right, so when we derive B, we get dB dt, and we keep the H, plus now we keep the B, and we derive H, so that's our dH dt. There's our derivative right there. We have 1, 2, 3, 4, 5 variables. We're trying to find dA dt, the rate at which the area is changing, and the other 4 variables are right there for us. So we're just going to punch those in, and we have 1/2, all right, and then dB dt we said was 14, H is 7, plus B, which is 24, and dH dt, which is negative 48.